We're here today, perhaps unsurprisingly, to talk about visualization. But this isn't the talk where we'll go into detail about William Playfair, or John Snow, or Charles Minard, because I want to talk about the word visualization. What do we think of when we hear that word? And perhaps more importantly, what does the public think? And what do our clients think? Right now, I'd say a lot of people, when they think of visualization, think of this, right? And this is great, right? This is fantastic. There's this amazing proliferation of toolkits and great examples, and visualization lives on the web now. And I think it's pretty easy to make the case that we're in a golden age of web visualization. I find this completely fascinating and amazing because I think back about 8 years ago when we were working at IBM Research, building Many Eyes, and doing truly unholy things with Java applets and client-side screenshots. And really, it was based on this hypothesis that, hey, maybe the web is a good place for visualization. Maybe there's an audience beyond visualization researchers and data artists. So to see this come about is truly an amazing thing for me. And yet there's something that makes me just slightly uneasy about it. Like maybe we're missing part of the picture. So to look at this idea, we'll start here with the digesting duck. As you can see from the diagram, there's a little arrow. Food goes in one end, and on the other end, you get duck poop. This was a machine made in 1739 by Jacques de Fauconson, and it caused quite a stir. I was a little bit disappointed to find out that it didn't actually do the conversion, that there were really just two containers. And it didn't look like that, really. It actually looked like this. But even so, it had its fans. And really, this was part of a larger culture of mechanical curiosity, right? We're talking about the Industrial Revolution, where people can make things, and there are all these amazing things that can happen with the technology. And so there was a whole genre of automata, and not just the duck and not just the mechanical Turk, which I'm sure you've heard of, but also things like this. This is a creation of Henri Miardet, and this is essentially a wind-up toy that draws pictures. Right? He was a master of this. He made quite a number of them. Some of them played music, wrote poetry. And this is the kind of thing that was really popular with the upper classes during the Industrial Revolution. Right? No TV, but you could hang out in your parlor and you could see some really wild demonstrations and some fakery. And it was all sort of part of the age and the interest of the age. And it was in this context of mechanical invention and demonstration that the world first saw this machine. And some of you may recognize this as Babbage's difference engine. And you can see the similarities, right? I mean, it's math instead of drawing, but it's kind of this neat mechanical trick. And it was shown in that setting. Of course, Babbage knew that there was something more behind it. You know, he didn't feel that he was making the next digesting duck when he made this calculating machine. And I can't shake the suspicion that that's why he looks so grumpy in portraits. Luckily for us, though, the story doesn't end with Babbage sitting grumpily in the corner. This is Ada Lovelace. Ada is a very interesting woman. Her father was Lord Byron, actually, the poet. Her mother was Anne Isabella Byron. Her parents separated early in her life, and this led her mother to encourage her to maybe stay away from poetry, but take a look at mathematics and logic. And happily, for us, this is what led her to Babbage and his demonstration. In July of 1833, when she was 17, she first saw a demonstration of a model of the difference engine. Thankfully, we have a record of this event. A family friend of hers was present, and she wrote this: "While the rest of the party gazed at this beautiful invention with the same sort of expression and feeling that some savages are said to have shown on first seeing a looking-glass or hearing a gun, Miss Byron, young as she was, understood its working and saw the great beauty of the invention." And this was true. She saw something in it that none of the other people in the room saw. And even Babbage himself realized this. He later wrote, "She seems to understand it better than I do, and is far, far better at explaining it. And they collaborated for a number of years after this. But I think the best way to show exactly what she saw and how far she saw is to quote from Ada Lovelace's own writings. Now, these writings come to us in sort of an unusual form. There was a book written about the analytical engine, which was sort of the next version of the difference engine. It was written in French, and Ada took it upon herself to translate it from French to English, and then wrote some additional notes. These notes are 3 or 4 times the length of the original work. So this was her opportunity to really say what she thought. Among many other things, she says, "It may be desirable to explain that by the word operation, we mean any process which alters the mutual relation of 2 or more things, be this relation of what kind it may. This is the most general definition and would include all subjects in the universe." That was 1843. So with that, we're well out of the parlor, right? This is not a trick. Ada saw where this was going and pointed in the direction of generalized computation, which is an astonishing thing. So I'd like to posit that if this is visualization's industrial revolution, then the web is our parlor. If you search for "check out this cool visualization" on Twitter, you get pages of this, right? And this is great, right? Don't get me wrong. Like it's fantastic that people have this level of interest, that they're sharing these things, that there's a developing visual literacy. But I worry that the kind of work that gets shared this way has a sort of homogeneity to it. And this becomes all that people see and all they think of. So I wonder if the public is seeing a kind of visualization monoculture, right? We here know that the ecosystem is much richer than that there's all this great variety. If people thought that art was just something you could put on a frame on a wall, then they'd miss out on sculpture, theater, sound art, all these forms. And yes, that would be bad news for artists working in those media, but that also means that there are whole swaths of experience that people are simply not seeing. So I really do think of this as an ecosystem issue, as a kind of biodiversity of our field, which I suppose is fitting since I first heard about monocultures from Michael Pollan's writing, although the term is much older than that. And he, of course, is probably best known for his terse recommendation, "Eat food, not too much, mostly plants." And thankfully, we have the Michael Pollan of code in our field. Thank you, Mike Magursky, for this. Which is perhaps a slightly tangential point, but really I think it is our job to show that visualization is not this monoculture. So how do we do that? I think we do that by expanding what people think of when they see this word. And why does this matter? This affects client expectations, right? If clients and people who are interested in actually creating visualization work or commissioning visualization work only know of this little slice, that's what they're coming to you to build. And that means every project, if you want to do anything different, has to start with this education of saying, well, it's not really about which visualization technique we pick or which library. It's about solving problems, understanding them, and then solving them. And even worse, it may be that there are people who perhaps desperately need a visualization approach, but don't think it applies to them because they've seen, some cute visualizations and they think that that's what that word means. And it also matters for aspiring practitioners. People get interested because they see what is out there and they want to do something like that. And we want them to succeed as well. And I think we need to make a conscious effort to push beyond parlor tricks, even if we're still in the parlor, so that when the next 17-year-old girl shows up who's going to blow this wide open, they see something in what we're doing and can take that to the next step. So I think this is about the variety. Right? It's all of these things. We want things that capture the public imagination, but also new experiences and new tools. And we want to apply these tools wherever we can and open up the possibilities. So I think it's time for visualization's Lovelace moment and really tackle all subjects in the universe. Admittedly, kind of a bold goal, but I think one way we can start working on this is for those of us who are doing work that isn't easily shared on the internet, that isn't sort of a self-contained experience that people can see and get, we can't be the grumpy Babbages sitting in the corner just complaining that no one understands it, right? We need to do the hard work of communicating the context and the reasoning and the benefit of this work. And it's a difficult thing to do. It's something that we've been struggling with in our own work, but in the spirit of trying to chart this course and to spark a conversation, we'll now get to the space robots you've been waiting for and some stories of visualization and JPL.
In the work that Jesse and I are doing at the Jet Propulsion Lab, we're often struggling with this question. And something that we observe that seems to tie so many of the visualizations together that are easily consumable is that if you take some kind of question or idea that they address, it's too often easily bounded. And I think we were confronted with this staggering difference of the things that we could do when we thought, how do we apply visualization to the search for the origin of life? It's not really a problem that we can feel like is easily bounded. And so we were trying to figure out how to make things that would ultimately not be standalone and things that can help the world to see what everyone in this room knows visualization can do. So I think one of our most shocking observations is, given the depth of the kind of conversations that we're trying to have with the scientific community, the request that most often is communicated to us, show me my data. People knock on our door, and this is what they ask us to do. Why is this the question that they ask? To some extent, we're wondering if this isn't a failure of communication on our own behalf, where we're taking, where the true individuals who could benefit when visualization starts to explode don't understand all the capabilities that visualization has. So the approach that we're taking at the Jet Propulsion Lab is to try and, instead of have people come to us and ask us for the mundane, to try and put our most audacious claim forward. And we're hoping that this is ultimately what people come to us and ask us to do. So for us, that visualization can change how we do science. As you might imagine, this would pique the curiosity of scientists. So this is the claim that we're making to our community. So I'd like to present two examples of the way that we are trying to prosecute this case to the scientific community at the Jet Propulsion Lab. So the first is Mars. Some of the most clearly popular images that come out of the Jet Propulsion Lab are the robots that we make, and they're beautiful. I understand why people want to embrace them. But the true star of the show at the Jet Propulsion Lab is science. And while Curiosity is a beautiful robot, she is also really the world's most expensive telescope. And this is what it looks like to see through her eyes. And this is how our scientists currently explore the universe. So this panorama that I'm showing is images stitched together in a cylindrical projection. Now, scientists prefer this method because the panorama seems to give them a landscape and a horizon that feels very real. However, there are significant challenges that are introduced in using an image like this, and one which we started to wonder if there would be some benefits of changing the way we present what other worlds look like to the scientific community. And one of the real challenges is because this is how scientists are trained to explore the world. They use their senses, right? They're able to see how far things are, the relative size, There's an atmospheric perspective that changes our understanding of objects and the distance. Our senses are highly tuned to work in the first person. So when scientists have to form an entire picture of another world through a computer, we became concerned that what happens if they don't develop a reliable mental model for what's out there? And even more complicated, what happens in scientific operations? So what we do is scientists independently develop ideas. How did Mars come to be the way that it is? And then curiosity goes to a place and conducts an experiment to help them validate the idea. So operations means telling curiosity what to do based on what everyone sees as the landscape. But what happens if they don't see the same landscape? We decided to experiment with different ways to examine this data. And so we've started to work with off-the-shelf head-mounted displays that provide immersive virtual reality. So you'll see this video here shows that we've created a way to have scientists actually walk on Mars. So we've taken the ability to display of a head-mounted display to capture rotation, added motion tracking, and created a tracking volume that scientists can now walk within. Now, the real computer magic was in taking the sensor data, which is not designed to do this, and combine different cameras that provide both point cloud and panoramic data into a single geometric model that we can then let scientists walk in. And this allows them to have a first-person perspective on what it's like to be on Mars. And so the first thing that our engineers did is they looked at the rover, which we thought was very interesting. But the scientists get a very different perspective, and they look on the ground and they actually get to see the rocks from different perspectives and rock their head back and forth. So we thought, well, since our job is to communicate to scientists, what we decided to do was conduct an experiment. And so we decided what we would do is take this same exact image that scientists use every day to identify, to understand Mars, and we'll place landmarks that are indicated by the arrows. And what we'd ask scientists to do is to draw a map. So a overhead planar, 2D planar projection of the space, and to draw where all the different points are on the map. And the closer the map that the scientists draw to the real map, the more accurate their internal mental model is of the actual space. So let's look at the data. So, apologize, it's a little complicated, but I'll walk you through it. And then we had two conditions. There's a condition where we gave scientists the ability to experience this using immersive virtual reality, and another condition where we asked scientists to compare, to make the map using the panorama that they're trained to use. So if you look, the X of each color represents where the ground truth is, where the landmark is actually located. And each one of the dots of the same color represents where the scientists placed the dot for that particular landmark. And we've drawn a bounding box around all of the dots to give you a sense of the area. So how good were the scientists at locating each particular point? So what's kind of staggering is to look at the difference. When we look at the panorama, this is probably the hardest thing to reckon. Is you can look in the middle and you can see that there's actually 5 rocks that overlap. So a scientist might be saying, look at that rock, and they could be all thinking of 5 different rocks. So we're now trying to present this to the scientific community and offer them an additional tool that shows a new way that we believe to visualize what this other planet looks like. And when we make these presentations, we're standing on the chairs and we're shouting, visualization can change how we do science. And we believe with this powerful new tool that we want people to hear this and come to us and ask us, help us change science, help us make better tools. Second story. This is the 70-meter antenna at Goldstone, California. It is part of the Deep Space Network antenna array. This is basically humanity's Ethernet port to space. So all the communications from every deep space asset that NASA, ESA, JAXA, all the world space agencies have go through the Deep Space Network. So it's truly a precious resource. There are 14 antennas arrayed around the world, phased at 120 degrees, so that at any one time, one of the antenna arrays is pointing at a section of the sky. So we could constantly communicate with every space asset. Now, these are, as you can imagine, enormously expensive to operate, and they are all operated 24 hours a day, 7 days a week, each of the 3 stations. And the way that the stations are operated is undergoing change. And this is the point when the operators have been for years looking at just tables and tables of data, and this is how they maintain an understanding of what's happening, right? It's basically tailing a log file. It's actually what they're doing. And so this really was good enough up until today when they're trying to make it so that instead of staffing each antenna center 24/7, they'd like each one to control the entire global network for just the daylight hours. So we call this follow the sun. And basically, each center's workload is going to triple. So tailing the logs is not going to work any longer. And the Deep Space Network program officers realized this, and they came to us, and what is it that they requested? Show me my data. For this particular problem, this simply couldn't be the answer, because you could never see all the data. And it wouldn't be the answer, because you'd never want to, even if you really could. It would be a headache. And, you know, to the credit of the Deep Space Network program, they realized that their problem was so hard that different parts, that the whole thing would not need to be visualized. And so they asked us and realized to decide what to visualize and help them make that decision. So the customer genuinely cared about what we should visualize and asked us not just to help them throw a technology at something, but to decide what problems they should be answering. So one of the things that we thought you'd want to do here is present multiple levels of detail. So you could start with a super high level and then go to the even more detailed and even more detailed and even more detailed. And then we tested it, it turns out totally wrong. It takes operators a really long time to navigate a hierarchy of the depth of the Deep Space Network. So we just use these very simple visualization techniques to create well, the work in progress. And what I'll show here is at a very high level, the display that we've come up with that allows operators to actually see, now this is 8 antenna, not 14, but it's an early prototype. And what we're doing is trying to give people the ability to see the whole network at once. So this is going to look like a lot of boxes and a lot of numbers, which it is. But it also allows operators to watch and to be able to see, for example, we're going to look at the bottom left. MOM, which is the best named spacecraft ever, an Indian mission to Mars, Mars orbital mission, is about to enter a track. And so you can see the track has started. And once we gain lock, the entire space will turn green. And then on the left, you'll see that the spacecraft started its downlink, and above it, this now means that we've started to uplink commands, and now we've got downlink lock, and soon we'll have uplink lock, and then the operator wipes their brow, and they don't have to pay attention to it for another 10 hours. Except for now, when something happens, and they're able to see very easily that, oh my God, we lost lock, but no, it's actually, multiple spacecraft passed. They should have lost lock. There was an occultation, but now you can see with the box around it, okay, everything's good. So we've taken this basic vision, this really simple idea of this, what we call the postage stamp, and we've done things like just plotted them out, in an ordinal fashion for each spacecraft so that an operator could look at what are the order of operations that they should be looking at. And so they could not only look at the display and see what's happening at any one time, but they could look at it and see how should the entire day look. And then really under development is this larger display, and the postage stamps are just part of a larger display. And so you can see this is the most detailed level of information that we provide. So I think the solution that we provided here, it doesn't have the sort of visual sophistication that I think so much of the work that is presented here has. And yet, the program officers are walking back saying, holy cow, visualization literally changed the amount of science that we're able to do. We're now able to actually magnify the number of passes that we're able to do because we could make more of a smaller number of deep space operators. So by taking just even the most basic visualization techniques, but working with the different scientific communities, we've tried to provide and learned that it's important to communicate that the sort of topmost capability of visualization is something that is profound. And we want people to come to us and ask us for that profundity.
So that's the way we've been framing a lot of our work. But I think this is about the future we all want, and that will mean different things to different people. And whether or not that involves space robots or commuting with Voyager, I think pretty much everybody in this room is excited about creative solutions to hard problems and expanding human experience and knowledge. And I think it's our job to create that future for ourselves by showing this diversity and working hard to communicate these things that aren't as simple as sending a URL around or retweeting something. So when we talk about visualization, what I think we're really saying is provide a complete picture, where the complete picture is the complete picture that you want people to see so that you can do the work you want to do. And that's part of our job as well, to set up that path to our own future. So we know what this can mean. Let's make it so our future clients and collaborators hear as much possibility in this word as we do. Thank you. We'd also like to thank the group that we're in, the Human Interfaces Group, the Operations Research Lab where we work, all these other groups that have supported the work we're doing, the people who worked on these particular projects. Obviously, we didn't build all this stuff on our own. And also Howard Rheingold for writing Tools of Thought, which contain the story about Babbage and Lovelace. We're contractually obligated to have this slide up here as well.
Hi. I really like what you guys said about flawed mental models lead to poor decision making. And a lot of this festival is focused on the experience part of data visualization, but then there's also the tool building side. So there are the artifacts and there are the tools. And I'm a data visualization tool builder, and I work for Microsoft. And I'm wondering, what tools do you guys use to create your dashboards? Or just any tools? What tools do you use?
I think for a lot of it, we use the same tools that probably most of you do. We use D3 for a lot of things. We've been using WebSockets to do a lot of the live updating. So we're benefiting from all of that great open source work and all those great examples as well.
A lot of the work that you guys show is based on data that you collected, and it's really people just inputting that data. How much work do you guys do that has more of a feedback cycle that people are able to actually input back and sort of alter the conditions?
So the work that we showed is really about monitor, but we are the human interfaces for the mission operations. So it's really about monitor and control. So control is really the next stage of the work that we're looking into. And so part of the work is just to build on the command line interface. But there's also a lot of wonderful work about dealing with the complexity of not just the robots of today, but the robots of the future. So there will be much more general purpose and complex robots that NASA will be operating in the missions over the next decades. So part of our job is to build command and control systems for those. And currently, it takes about a year for a PhD in computer science to learn the language. So it's hard, and what we're trying to do is just make it much easier for people in general. And so visualization is a big part of that. And we do have some of that work online if you're interested in following up, or we can talk offline too.
Thank you. Great talk, guys.
Thanks.
I think there are a lot of us who have the position of building tools and designing visualizations that require us to really marry up domain knowledge and the work that we do. So it might be financial, it might be science of other kind. What kind of advice do you give to people well, I'm asking for advice. What kind of advice would you give me and anybody else who wants to do that, and how to bridge that gap between the folks who really don't know anything else except show me your data, and other than saying, look, let's walk through a story and let's go through a use case and a user story.
Well, I'll start by saying I don't think we've cracked that problem. I can offer one example of a thing that hasn't worked for us that might be helpful.
Yes, it's good.
We've been thinking of ways to basically make the case that we can solve these kinds of problems, right? And we haven't been doing this at JPL for very long, so it's not like we have 10 years of work there to say, look, this worked for all these other groups, right? And I think there was a desire for both of us to explain the methods as a way of saying, hey, well, we use user-centered design and we do prototyping, and that means we have this wide range of opportunity, right? But we were talking about this the other day, and we were saying that it's kind of like you want to communicate biodiversity, and instead of showing biodiversity, you lecture them on genetics, right? It's like, it just doesn't work. So I'd say, like, at least the high-level thing we've learned from that is we have to be speaking their language and spend our time understanding their problems and their vocabulary and try to get in from that angle. But I think there are sometimes dangers in just showing a lot of work that isn't relevant, because they'll just sort of like, oh, I like that one, and that looks nice, and that looks good, and could you make me a tree map of this?
Yeah.
And it's a challenge to make it the higher level question.
So you take on a lot of that yourself to try to learn what the domain's about so that you can do more of the version.
We do,
Yeah.
we do, and that's expertise that we're building within our group. I think it's really the only way for us to make that work in that environment.
Sure. I think the other is by having a rich set of examples about cases where visualization has produced huge impact, and not to talk about it as a tree map, because you don't want people asking for tree maps. You want them asking for the things that tree maps do. And so by focusing on those benefits as opposed to the features, and I'd say having a rich portfolio of things that I think would probably need to go much broader than our own work. I mean, we have to show things that come from all different areas. And I think last, we're hoping that that this becomes easier and easier to do as we all do it, and the ecosystem becomes richer. And so by you doing it everybody in the room's customers will learn about it, because your customers will talk to other people and they'll see it and read about it and pass them around. So we're hoping that by starting this communication, it's not just something that gets better for you and the people that you interact with, but that we communicate much more broadly that there's something that we think visualization can offer, and that is exciting to people enough, exciting enough for other people.
So I'm coming from the sciences, and I'm curious about how you see the future of visualization at JPL. Do you see yourselves as kind of becoming a even stronger centralized hub that that treats the different groups as clients, or do you have a vision for kind of educating and building these capacities within the groups?
I hope it's all of those things. I mean, we have a lab with 5,000 researchers and an infinity of problems. So it's a really rich place to work. I think one of the things so there's also way more than we could ever do. And even with a deep group. So actually last year, we put together an event that included Jer and Eric Rodenbeck, who's in the room, and Martin and Fernanda. We actually brought a lot of the individuals who you have who are visiting here to come to JPL, and instead of really talking about the most delightful of our works, it was really about just like what is visualization. And we asked everybody to start at the very beginning. And the outcome of that particular event was to build an excitement. And that's why people are knocking on our door, right? So we saw some good come out of that. And we think now the next step is to try and make sure that they understand the things that visualization can do. So we really want to educate and to raise the level of skill. You have scientists who program and who could learn some of the things that they needed to do. So I think it would be delightful, and one of the reasons that having tool sets available, like the ones that all of us use, and so easy to use, is that they do try. And so it is delightful. We actually have people come and show us some of the things that they made, and they said, what does this mean? And so we get to work with them in that way too.
Hey, sorry, I'm way up top, but I have a question. I'm waving now, so you can sort of localize me.
Thank you.
I'm curious about the organizational schema for the dashboard, and like you showed progressively more complex views of those postage stamps, and also about the order, particularly of the postage stamps. I noticed that they kind of have a periodicity to them, or like a periodic table appearance, and I'm curious if they're ordered in a particular way, or if you did a lot of research to see, what is like the human ingest capacity, how many details can you absorb in one view, and where should the most important things be positioned. And like I'm sure you looked into like colors and how people, like what colors are the best for people to notice things. I'm not sure if that made sense. It was kind of just like a
Well, you don't always get to work with best when you inherit. So there's a book this big that just describes color in the Deep Space Network. So you have to listen to that book. But everything else is in scope. One of the things that we're actually doing right now is we've taken the postage stamp, we actually brought operators into our lab, created a simulated environment, and then we give them a distractor task. I believe it's right now that game where you pop balloons. It's for young children. And so we give them this like balloon popping game that really occupies them, and then we try and see how much, we ask them questions about the display and how things changed. So we're currently working on an experimental setup to test cognitive load, because what we really want to report to the network is this is about the edge of where people can handle. This is a bad idea.
They've gone too far.
Right. We basically want to tell them where that line is, in addition to designing the display so that it is most available. And then in terms of the actual physical layout, I don't think we've touched that yet, but we've got a long way to go.
Yeah, well, one thing we have found is that people customize their current displays pretty extensively. And they have their own feelings about where things should go and what colors they should be. which can cause problems when someone else comes by and tries to help them out. So I think there's an aspect of that that's more about allowing the customization, but kind of mediating these handoffs as well, and less about kind of an absolute best position. All right, thanks very much.